Okay, welcome to the class, students, and this is the last topic of your second semester syllabus. This is portion of nitrogen containing compound, which most of the part I have finished in the class, your physical class, and offline. That is, and also at Zoom before the physical classes. And so here this is diazonium salt. This is a quaternary salt of amines, nitrogen containing compound. You have done amines, and so this is a salt of nitrogen containing compound, organic compound. So this you have done in aniline chapter, in property of aniline. This is diazonium salt here, C6H5 N2Cl. There will be a positive charge on nitrogen, first nitrogen, and because of that positive charge, chloride ion is attracted, as we have done earlier in properties of aniline. So when aniline is treated with nitrous acid, this is nitrous acid, you have done this reaction in chemical property of amines. So nitrous acid is unstable acid. It is prepared fresh by the action of sodium nitrite NaNO2 and your dilute nitric acid or maybe dilute HCl, and then this HNO2, which is obtained fresh, is reacting with aniline. So here this is aniline. Aniline, you know this aniline, aromatic amine, combines with nitrous acid in the presence of dilute HCl when temperature is very low. 273 Kelvin means 0 degrees Celsius to 278 Kelvin, that is 5 degrees Celsius. And when it is made to react, we get this salt, and this salt is called diazonium chloride, benzene. This is benzene, benzene diazo, di means two, azo is for nitrogen, diazo. Nium plus sign is so ium, IUM, diazonium and chloride ion, so chloride. So this is your benzene, diazonium chloride. So you have obtained. Now directly you have to do the properties. Name reactions, as I told, are already important. First reaction is Sandmeyer's reaction, which is used for replacement of this group N2X, X is for halogen, N2X group by chloro group or bromo group, Br group. N2XX here, if it is Cl, then the replaced by chloro group, already chloro group is there, or by bromo group. If you have to replace it by bromo groups, here you have to replace by Br. So here you will take HBr. Okay, so in place of this Cl, then we will have Br chloro. Benzene we have obtained here. So if you take HBr, it will be bromo benzene. And N2, and this is as catalyst, will be obtained back as a product. So this is Sandmeyer's reaction. When the reaction is done in the presence of cuprous chloride, this is dimer of cuprous chloride. This is not cupric chloride, this is cuprous chloride. Now, the next reaction is Getterman reaction, which is a modified Sandmeyer reaction. Modified form of Sandmeyer reaction is Getterman reaction. In this reaction also the same thing is there. Your N2X group is replaced by chloro and bromo group, chloro or bromo group. So here only compound is changed. In place of HCl, if you take the HBr, here you will have obtained bromobenzene. So in place of cuprous chloride, copper powder is taken as a catalyst, and so then the reaction takes place. So this reaction is less complicated than this, but in both the cases you have seen here Cl is also there, Cl minus. So this group is replaced, chloro group is replaced by bromo group also if we take in place of HCl HBr. So this N2 will be out and this Cl will be attached, and if we have Br here, so in place of chloro, bromo benzene will be obtained. So in this case also your N2X group is replaced by either chloro group or bromo group. What is the difference? Here cuprous chloride is taken as catalyst and here copper powder is taken as a catalyst. Third reaction is Bell-Scheinman reaction. In this also your N2X group is replaced. N2, N plus and X is your halogen. This will be replaced by a fluoro group. First two reactions were for a replacement of diazochloride group by chloro or bromo group, but in Bell-Scheinman reaction by fluoro group. So here the reaction is carried on Bell's this is Scheinman reaction, and then here again diazonium chloride reacting with HBr, which is fluoroboric acid. Hydrofluoroboric acid, or simply called fluoroboric acid. You can also call it fluoroboric acid because acids have hydrogen in them. So hydro, if you don't write even, then also it is correct. So here the reaction is taking place. This part is remaining as it is. Then this BF4, this HCl, H from here, Cl from here is out, HCl is out, and BF4 is attached here. When this is out, plus charge here is out, so one negative charge will be developed. This is called benzene. Diazonium, nitrogen, two nitrogens, so diazo, positive charge, so azonium. Tetrafluoroborate, the salt of boric acid is borate. So tetrafluoroborate, which on heating will liberate BF3 out, nitrogen gas out, and will turn into fluorobenzene. Fluoro, FLO, FLU, fluoro, FLUO, fluoro, benzene. Now, next reaction, replacement of N2X group by hydrogen. That is this group by hydrogen. This is metaphosphorus acid. H3PO2 is metaphosphorus acid. Combines with water, means hydrolysis. In the presence of cuprous, copper plus, cuprous ion, and this N2 is out as a gas, HCl is released, and metaphosphorus acid will be converted into phosphorus acid and benzene will be set free. So diazonium compound is turned into benzene by this reaction. Now replacement of this N2X group by hydroxyl group. For hydroxyl group you have to hydrolyze it. Hydrolysis will be taking place in the presence of sulfuric acid. few drops, and then you have to either boil it or you have to steam distill. Then nitrogen gas will be out, HCl will be out, and in place of this OH will be attached, and this is your phenol. So in this case you will obtain phenol, and here you have obtained benzene. Next reaction we'll do now. Reaction with the next property, replacement by nitro group. This N2Cl group, diazonium chloride group, will be replaced by nitro group, NO2 group. When it is treated with boric acid, tetrafluoroboric acid or fluoroboric acid, then HCl is out. This is out as HCl, and we obtain, this is HCl is out, and we obtain benzene diazonium tetrafluoroborate. We obtain this salt, and when this is treated with sodium nitrite and copper as catalyst and heated, we obtain nitrobenzene. Nitrogen is liberated and sodium borate is out. Next reaction is coupling reaction. Coupling reaction is very important, and it is a test for diazonium salt also. Is also a test for phenol and for aniline. So coupling reaction means reaction of diazonium salt with highly reactive aromatic compound. Highly reactive aromatic compound means aromatic compound, that is benzene ring, is having a group attached to it with a lone pair in this. So examples of such group which are highly reactive, in which group is having lone pair, is phenol, you can see lone pair, and aniline. So this is aniline here with a lone pair. So when this combines, temperature is same in both cases, 0 degree Celsius to 5 degree Celsius, or 273 Kelvin to 278 Kelvin. Here pH is maintained between 9 to 10 by adding some alkali. So medium is alkaline, and we obtain para-hydroxyazobenzene. Para-hydroxy, this is now not getting a status of functional group, so hydroxy. So at para position, hydroxy group, and this is the main group. This main group is azobenzene. So azobenzene, till here it is azobenzene. This is your azobenzene, and at para position it will be considered hydroxy, which is a dye, a colored substance. Dye, remember that, a color substance. Aniline also shows the same reaction under the same condition, but only the medium is changed. Medium, you can say pH is 4.5, medium is acidic, and in place of OH here will be NH2 at para position. So para amino azobenzene, and this is also a dye, orange color dye, bright color, and it is found that if suppose aniline is having its para position occupied by some other group, then this coupling reaction will take place at ortho position. Coupling reaction takes place at para position, and if para position is not free, then ortho position. So in substituted phenol and aniline, this coupling reaction, this diazonium salt will be attached to the para position, and if para position is not free, it will be attached to ortho position. So that's all about your diazonium salt. So syllabus is finally finished.